Wait, well, Daniel got extra.
Oh, I didn't. Did you? I finished it. I corrected it all right this morning. Ray Daniels to 82. Who else? Training corrected theirs.
Okay. All right, guys, we are going over 7.3. We're going over 7.3. We have number one. We that's what the graph should look like. We're going to go 2 to the left. So x minus 2, y plus 4 is my rule. Remember, I asked you to go and label x and y. Okay, I'm going to move it 2 to the left. Each point, 2 to the left, 4 up. 2 and 1, 2, 3, 4. There's my B prime. Some of you don't label as you go and then you're confused. 2 and then 1, 2, 3, 4. Should I get the same exact figure? Should it be congruent? Yes. And then I'm going, that is 2.5. So I'm going to go 1, 2, and then up 4. It's going to be right there in the center. C prime. And then over 2, up 4. D prime. Okay, so my coordinates are what? 3, 2, 0, 2. You would not believe how many people put 2, 0 right there. Guys, it's X, then Y. X comes before Y in the alphabet. It's 0, then 2. You don't have to walk to the elevator. You just go up. You're at the elevator. C prime is 0.5, negative 1. Some people put 1. Then D prime is 2.5, negative 1. Guys, remember what you could have done? You could have subtracted 2 from all your x's and added 4 to all your y's. You could have done the math on that sweet little calculator you get. Just saying. Okay, number 2. I'm not going to do that one because it's pretty easy. You take the original graph, you go 5 down. What goes up and down? Y. What goes left and right? Please raise your hand if you did that for me. You went over there and put the X and the Y. 1, 2, 3, 4 people. I promised you the first day of school, and I've promised you several times since then. If you will just follow what I ask you to do, the little tricks I'm showing you, you're going to make better grades, and you're going to learn this more. And I still have people that won't get on my bandwagon. How many people's in here, Miss Kent? 20? Or not? I can't remember. 20 minus 4. So 16 people's not on my bandwagon yet. Rut-row. So, because that's why some of you missed this one. You did it backwards. X goes right to right, and Y goes 5 down. 5 down. So I'm going to add 2 to all my x's. That's going to be negative 3, negative 1, 2, 3. I added 2 to all my x's. Now I'm going to subtract 5 from all my y's. Negative 3, 0, 0, -3. Do you know what a lot of people put right here? 0, -1, and 0, 2. Guys, we've got to learn the difference. The point is right there. That's -1, 0. 2, 0 is right there. Okay? Number 3. I'm just going to put B on there. 2, 2 is B. -5, 1. A lot of you put -1. You put it in the wrong spot. And then what I need to do is tell how far they moved it. Well, everybody put your pencil on B. Everybody put your pencil on point B. We're going to count, and we're going to go 1, 2, 3, 4, 5, 6, 7 left, and 1 down. What goes left and right? X. What goes up and down? Y. Let me fix my paper. So the rule is X minus 7, Y minus 1. Some of you made up your own version of how to do a rule. It made no sense. Crazy stuff. Some of you put some crazy stuff down there. That's all you had to do. Okay, number 4. You're going to graph -2, 4 is A, -4, 5 is B, -3, 1 is C. And guys, some of you didn't label. We're going to reflect it over the x-axis. Some of you went over the y. Remember I told you that was, you be careful, that's where kids made a mistake. And guess what? You weren't careful. You didn't do what I said. Circle the X, draw your line on X so you would go over the right road. And look, guys, you just flip over each point. That's C, so that's C prime. B is 5 away, so I'm going to go down 5. A is 4 away. I'm going to go. It's got to be a reflection. The rule, when I go over the x-axis, somebody tell me the rule.
X stays the same in the -1.
That's all you had to write, people. X, -y. X stays the same, y is the opposite. Okay? So if I go over the y-axis, what is my rule going to be?
-X and then Y.
Boy, some of you made up some crazy rule-looking stuff. I've never seen such. You didn't see it in here, because I've never even seen it. If you're going over the y stays the same, x is the opposite. That's all you had to write. You're trying to make it way complicated. Way complicated. You're going over the y, so you should have flipped it over the y. It started here. You should have ended up in quadrant 1. I'm not going to draw it because you can draw. Okay, number 6. Reflect it over the y-axis. Yes, this looks a little strange. But guys, what did I do on this to reflect it? Did I do all of it at one time? No, I took the B and went to B prime. I did the C, then the A. That's the same thing you do down here. I reflect each point over the y-axis. So A is on this side. One away from Y. I'm going to put A prime, 1 to the left of Y. C is 3 to the left. I'm going to go 3 to the right. B is 2 away. I'm going to go 2 away. Then I'm going to draw my figure. I just reflected it over the y-axis. What happens when I go over the y-axis? The x is the opposite, or you can say x changes signs, y stays the same. So what's the rule? Negative x, positive y. Easy. Okay, number 7, reflecting over the x-axis. So again, guys, you go over the x-axis with each point. I'm going to give you a minute to do it. Go. Reflect over the x-axis. Each point, if you missed it. Take A, change A. Flip A over the X. Flip B over the X. C over the X. Okay, so X stays the same. Y changes signs, or Y is the opposite sign, however you want to say it. So how am I going to write the rule? Positive X? Okay, that doesn't mean that on every point, X is going to be positive and Y is going to be negative. Let's don't say that. It's just X, negative, opposite of Y. X, opposite of Y. X stays the same, so put X. Okay, on the next one, -4, -2 is X. -1, -5 is Y, and -1, -2 is Z. Okay? We're reflecting over the x-axis first. So you should end up with it in quadrant 2. I'm just going to do X because of time. So X prime is going to end up right there. Where is X prime? What is that coordinate? -4, 2. Guys, I do not understand why that was hard. I do not get it. You went over the x-axis. You just flip X over. It's -4, 2. Now I'm going to move it 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. There's X double prime. Where is X double prime? 4, 2. You should not have anything in quadrant 4 because it didn't tell you to do anything there. Flip it over the X, move it 8 to the right. Put this in graded papers. Whoops. Okay. Now, everybody look. Look at me. When you translate, you're sliding, aren't you? So you're adding and subtracting to the X and the Y. And the same figure. So it's congruent. When we reflect, we just flip the same figure, don't we? We just flip the same figure so it stays congruent. When we rotate, we take the figure and rotate, turn it around so it stays congruent. Today we're going to dilate. Dilate. That means we're going to make it either larger or smaller. So we're going to change the size of it. Now it's going to stay the same shape, so it's going to stay proportional. You know how you did similar figures last year? You know how you did similar figures last year? They stayed proportional. That's what we're going to do today. But we're going to do it on the coordinate grid. We're going to do it on the coordinate grid. We're going to take figures, pre-images, original figures, and we're going to dilate them. When you go to the eye doctor, some eye doctors sometimes dilate your pupils. They put drops in there so they can, your pupil enlarges and they can see in there if there's anything wrong. Dilate, well, it means, I thought it just meant get larger, but it also means to reduce. Sometimes I take papers and I go reduce them on the copy machine by a certain percent, which changes to a fraction. Okay? So, we're going to dilate figures today. The only problem is we've got to put them on the right place on the coordinate grid. No big deal. I've got a trick for you to use. How about that? When we rotated, the center of rotation was the origin, right? It's going to be the same way today on dilation. That means we can use the coordinates again. That's the trick. When the center of dilation is the origin, you can use the coordinates of the vertices. Okay? So when you look at this paper right here, when you look at this, which one of these is the pre-image? The little one. It's not always the little one, but it is on this. So that's the pre-image. Hey, and just do an arrow. That's the image. So we've got a pre-image and an image. Pre-image and an image. It tells us, guys, the scale factor is 2. Factor means to multiply. Okay? So we're going to multiply by 2. We're going to multiply the sides by 2 and the vertices coordinates by 2, which they already did it for us down here. So everybody look at the bottom. What they did is they took all the vertices, the scale factor, right, SF. You're going to be doing that a lot. SF is 2. So that means they took all these vertices and multiplied by 2. You see? So you would know where to put it on the coordinate grid. Now, look at that. So they put them on the coordinate grid for you. Let's count B, C. How many units is that? 4. How many units is B prime, C prime? 8. Now, what's 4 times 2? 8. Now let's count AB. What's that? 8. And count A prime, B prime. You already counted them? Or you just said 8 times 2 is 16? Well, we got to count them. Okay, 16. Good. So, they made it 2 times bigger. But you can't just put it anywhere on the coordinate grid. I'm going to show you something that works out every time. Since the origin is the center of dilation, usually kids find this fascinating, and you'll see why in just a minute. I was confused because the first one I did was this one, and look, the origin is in the center of both rectangles, so I thought that was how it was going to be every time, and you'll see on the next problem we do, it's not. In fact, we won't do another one that looks like this. And so that's why I was confused. I thought, oh, well, I've drawn it wrong. Something's not right. But look, all you have to do is put your ID down, and match up the A and the A prime. Match up the A and the A prime and draw a line through it. You should be drawing it through the origin. It should go through the origin. When you line up B and B prime, which matches up through C and C prime, D and D prime, excuse me, then it goes through the origin. That's how you can check yourself to see if you put the image on the coordinate grid correctly. All you have to do is match up the vertices, the image to the pre-image. Okay? Now, let's pretend for a minute we don't know the scale factors 2. I'm going to show you how to get it, because sometimes that's what they want you to do, is find the scale factor. So what I'm going to do is put SF. I'm going to put SF up there. SF. Guys, you know how celebrity messes up sometimes when they do something pretty stupid. Well, their publicist tries to get them a new image. They have them singing at a hospital. They have them donate money to an orphanage. They may have done these things secretly, and nobody knew, but they make sure, the publicists make sure that everybody sees that they do this to try to help their image. So that's how we can remember that the new is the image, because it's easier to remember new and old. So we take the new dimension and divide by the old dimension. We take the new dimension, so we can take either one, 16 or 8. Which one?
16.
Okay, 16. And we divide by the old dimension, which is 8. And what's 16 divided by 8? 2. So the scale factor is 2, which we already knew, but I'm trying to show you how to get the scale factor when we have to do it in just a minute. Okay? Or you can take the vertices. You can take the vertices. We can take, A, B, C, or D?
C.
Okay. We can take C prime and divide by C. So C prime, which one y'all want to do, 8 or -4?
8.
8. Good. Thank you. So 8, and we divide by 4. And what's 8 divided by 4? 2. So you can take the dimensions and divide, or the vertice coordinates and divide to get the scale factor. Sometimes you can't do the dimensions because you don't know what they are, because they're on a slant on the coordinate grid and you can't count diagonally. And don't try to go measure. I have kids all the time. Hey, can I get a ruler? Can I get the... You just use the coordinate. Okay, turn the page. So what we're going to do is, it says label the X and Y axis. It's already labeled. We're going to graph the original figure, which is our pre-image. So let's go graph it. 0, 3. Label as you go. It's A. -2, 3 is B. -2, 1 is C. 1, 1 is D. What is this? Good. I'm impressed. It's a trapezoid. Everybody go circle scale factor of 2. What does that mean? Scale factor of 2. What are we going to do to get our new? We're going to multiply all the coordinates by 2, because our origin is the center of dilation. We can use the coordinates. So I'm going to multiply all the x's by 2 and all the y's by 2. So what's 0 times 2?
0.
3 times 2?
6.
6. 3 times 2 is 6. -2 times 2?
-4.
3 times 2?
6.
-2 times 2?
-4.
1 times 2? 1 times 2? 1 times 2? 2. We have our new coordinates. So 0, 6 is A prime. -4, 6 is B prime. -4, 2 is C prime. 2, 2 is D prime. Should our figure be congruent?
Yes.
No.
Oh.
No. 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 It's not the same size. Should it be proportional?
Yes.
Yes. Not congruent. We've made it 2 times bigger. Now, to know if we've got it in the right place, use your ID. Go line up B and B prime for me. B and B prime, line it up. Does it go through the origin? Yes. D and D prime? Yes. We're not going to draw them all on all of them. A and A prime go because it's on the y-axis. And C prime? Yes. Yes, it has the same orientation. Yes, I was getting to that. Yes, it's sitting in the same direction. Very good. It's not congruent, but the orientation is the same. Very good, Daniel. Okay. So we've graphed it right. It's correct. Now, let's go do B. We're going to do this one by half. We're going to take these coordinates, put on the graph. 0, 6 is A. Negative 4, 6 is B. Negative 4, 2 is C. 2, 2 is D. Very good. We're going to take half of these coordinates. Half of 0, 0. What's half of 6?
3.
Half of negative 4.
2.
Half of 6.
3.
Half of negative 4.
-2.
Half of 2.
1.
Half of 2.
1.
Half of 2.
1. It's just the same thing.
Good. Good. 0, 3 is A prime. Negative 2, 3 is B prime. Negative 2, 1 is C prime. 1, 1 is D prime. Yep. And let's just match up one. I'm going to do B and B prime. You do the one you want, except A and A prime, because it's already done. Okay, C. We good? Square ABCD was dilated to form A prime, B prime, C prime, D prime. What scale factor, everybody circle that. What scale factor was used to change square ABCD into square A prime, B prime, C prime, D prime? Okay? So, we're going to do it both ways that I just taught you. We're first going to take the dimensions. We're going to take the new dimension and divide by the old dimension. So let's count on the new. Which one's the new? The bigger one. Now remember, it's not always that way. It is the 2 times we've done it. This is the image. So Kristen counted and she got 12 on B prime, C prime. Okay? What is BC? 4. So what am I going to go put over here? 4, which is 3. Okay, it got larger, didn't it? So we knew, everybody come over here, right, the scale factor had to be more than 1. We knew it had to be greater than 1 because it got larger. If it gets smaller, it's going to be less than 1. It's going to be a fraction, like 1/3, 1/2, 2/3, 3/4, 5/6. It's going to be less than 1 if it gets smaller. You still multiply, you just multiply by a fraction. Yes. Well, you can sometimes, and I'll show you in just a minute. Yes. Okay. Now, we also can do our vertices. Okay? We can do the dimensions, or the vertices. Pick a letter, A, B, C, or D. Thanks for picking B. Thanks for picking B. Why would I want you to pick B? Positive. Good, Logan. What's B prime's coordinate? No, B prime. 6, 6, huh? And then B is 2, 2. So all you do is take one of them where they're the same thing. So 6 divided by 2 is 3. So you can take the dimension or the vertice and divide. New by old. Image by pre-image. Okay, look at D. As I read, please draw, if you know what to draw. Carrie drew an equilateral triangle, don't say anything, with a perimeter of 15 inches. What's equilateral mean? All sides equal. Oh, that's the best one I've drawn all day. That looked pretty rough this morning. Okay, equilateral, all sides congruent. What is the first thing your mind went to when I said that?
Triangle.
Triangle, 3 sides. What else, Willie? 15 divided by 3 is? Why'd you divide 15 by 3?
3 sides.
Thank you. Guys, that's what I'm trying to get you to do. When you're given information, you go on with it in your mind and think of something else. That's what we're not doing. That's what we're not doing. If I give you information, you should automatically think something else. If you don't, that's being lazy. Y'all all know that 3 congruent sides, so 15 divided by 3 is 5. You probably know that now, but if you'd have gone on and thought on your own, you would have known it. Quit waiting for me to tell you everything, okay? That's the difference between a great student and an average student or a poor student. The great students, they go on with that information that they're given and think of something different. You appreciate those great students because that's why you have those nice cell phones, iPads, iPhones, pods, all that. Because of great students. They went on and thought of something different. Nobody had to tell them anything. Okay? So, he dilated the triangle by a scale factor of 0.5. What's another name for 0.5? 1/2. See, when I said 0.5, everybody in here should have been thinking, oh, that's a half. Did you think that? Okay. What is the length of, don't say that loud, let everybody think. What is the length of each side of the image of the dilated triangle? Of the image. The length of each side. What is it? 2.5 inches. Where did y'all get 2.5? 5 divided by 2. Half of 5 is 2.5. Good. Okay, look at the next page. Number 1. Everybody circle 2. Scale factor of 2. What does that mean? We're multiplying all these coordinates by 2. So we're going to get the original coordinates. This is the old, the pre-image. Write this up there, please. This is the new, which is the image. This is the old, the pre-image. This is the new, the image. What would the rule be? What are we doing to each x? Times it by 2. What are we doing to each y? Times 2. Do you think you have to do the same thing to x and y? To dilate it? Yes. It's not a dilation if you don't do the same thing to x and the same thing to y. When you dilate it, you gotta multiply every x by 2, every y by 2, every side by 2 to make it proportional. So you're going to get the coordinates, multiply all of them by 2, and put your new figure on here, your new image. Hey, stop. On number 2, what's the scale factor? 3. So you're going to multiply everything by 3. You're going to get the original, the old coordinates, multiply all of them by 3 to get the new. And you're going to put that on there. How can you test to see if you're right? If you line up the vertices, the image to the pre-image, vertices, A to A prime, B to B prime, and it goes through the origin. Very good. Look on the back real quick. What's the scale factor for 3? 1/2. So we're going to multiply all of them by half. How do you multiply everything by half? Yeah, you can on the calculator by 0.5, or you just divide by 2. Thank you. Look at 4. Scale factor of 3/2. So you're going to multiply everything by 3/2. What is another name for 3/2? Or 1.5. So you could multiply by 1.5. So you're going to do 1 through 4. You're going to do 1 through 4. Any? 3/2 is 1.5, huh? Well, what could you multiply by? What's the decimal for 1/2? Willie? Okay. Well, what we do for the rule on 1? 2x, 2y. So on 4, you mean? What would be the rule for number 4? Hey, everybody. The rule for number 4. 3/2 x, 3/2 y. Correct? Okay. Good deal. Finish this and we're going to check it. Guys, we're going to have to check it tomorrow. So if you're working on it, you'll have to go to the next day's lessons to check it.